Okay, over here, this one is a little tricky, so I will work it through with you guys. No information at altitude, so my best bet is to go for the legs. Therefore, I have to look for hypotenuse over leg and set it up. Look at the biggest triangle. My hypotenuse is k plus 21. My leg is 10. And then look at this smallest triangle here. And you can go for this middle triangle, but notice there's no information about the hypotenuse of the middle triangle. So it's rather useless. Since I'm asked to find the value of k, I'm going to zoom in on the littlest triangle. And here my hypotenuse is 10 and my leg, short leg, is k. So that's a proportion. If I cross multiply, I would have k times k plus 21 equals 10 plus 10. 10 plus 10 is 100. And if I distribute k, k times k is k squared, k times 21 is 21k. If I then want to make this side 0, I can minus 100 on both sides. So right hand I have 0. Now on the left hand side, I have a fairly complicated trinomial. And this is where people freak out. Do not freak out. The reason, notice, why do we do, it's not that we are just daydreaming that we want to put a 0 on the right-hand side. We're doing that with the hope that we can rewrite this into two factors, factoring, right? We can rewrite this smart-looking trinomial into two factors, and then that would equal 0. Because if I can do that, I can use this property. If a times b equals 0, then either a equals 0 or b equals 0 or both equals 0. So that's my a and that's my b. That's what I'm hoping to do. So how do I do that? Quick review of factoring. Factoring of trinomials. I factor the first term, I write it vertically, k times k. Then I go to the last term, the constant term, negative 100. I'm hoping to find two numbers that I can eventually add together and get to 21. So negative 100, if I do a factor tree, maybe I'll do it here. If I do a factor tree here, let's do 1. Remember, these are all positive and negative on all sides. 1 and 100 obviously will not give me 21. I can do 2 times 50. I don't think I can come up with 21. Can't be done by 3. 4 and 25. Notice that if I can manage to do 25 minus 4, I would have 21. So the negative 100 can be factored into 25 times negative 4. That's how I would have negative 100. Notice again, I wrote it vertically. Now I cross multiply. This one would give me 25k. 25k. I cross multiply that would give me 4k. Sorry guys, let me write it a little cleaner. 25k minus 4k. Now I would have 21k, which is my middle term. Because I'm doing that, my factors are right here. This is positive. So in other words, I can rewrite this, I'm going to bring this up here, into k plus 25 times k minus 5 equals 0. And my k would either have to be negative 5 or k has to be equal to 4. Obviously, I cannot have a side length of a right triangle there, k, as negative, so it has to be 4. That's my final answer. Okay, so again, a quick review. Set it up as you normally do. You will end up with a quadratic trinomial, and then do factoring. How do I do factor? I factor the first term first. K squared becomes k times k. I write it vertically. I factor the constant term. But when I factor it, I try to pick a pair out of all of these pairs of factors. Pick a pair. Somehow they can add or subtract and becomes 21. And then if they have 21, they have my b term. My factors are right here, k plus 25, k minus 25. Oh, don't you just love it? Now that you see information on the altitude, you can use heartbeat. 2w over 3w equals 3w over 4w plus 3. That's a lot of w's. Let's cross multiply. 3w times 3w would have 9w squared. Be very careful with your powers. If I distribute 2w, 2 times 4 is 8. W times w is squared. And then 2w times 3 gives me 6w. Now, if I can get rid of, if I move everything to the left, if I minus 8w squared on both sides, I would have w squared on the left-hand side equals 6w. Now, some people go ahead and do the square roots. You are going to get stuck. I don't know if you can see this. You minus 6w on both sides. You again will have this equation that will solve, that will really save you. Again, this is a quadratic. It's a special quadratic equation because you don't have a constant term. That's okay. There are two ways of factoring it. One way is, do you see there's a w in both terms? I can simply take the w out. And then in the second term, I just use my original, each term w squared divided by w is w, minus 6w divided by w is 6. Everything else comes down. So my w can equal 0 or equal 6. And obviously, given the circumstance, I'm looking for side length, it can't equal 0 because then I won't have a triangle. So w equals 6 is the correct answer. Okay, now another way to do this is, I told you that you don't have to, once you get to this point, if you don't see this, you can still, I'm going to rewrite, let me change the color, w squared minus 6w. I can still use my factoring technique, but this time, because I don't have constant, I'm going to add a constant. See if that helps me. So if I factor w squared, I would have w times w is w squared. If I factor 0, how can I do anything times 0 is itself? So I can just do 0 times negative 6. That will give me 0. And now if I cross multiply, I would have negative 6w plus 0 times w, which is 0 all by itself. So that's how I come up with negative 6. And again, my factor is right here. W plus 0 times w minus 6 equals 0. If I simplify that, I get to the same place. This is, the blue part is really too mechanical, but the concept, you see, it doesn't matter how you do it. These are just math tricks that helps you arrive at the same answers. Okay, I'm not going to do everything for you. These two are fairly complicated, but it's really important that you get through it. So I'll set it up for you. Make sure you check your answers in the last two slides. Same thing here. I don't have information about the altitude, so let's go for the legs. Hypotenuse over one of the legs. Make sure you have corresponding legs. My hypotenuse in the biggest triangle is 2y plus y minus 1. My leg over there is y plus 1. Now I can look at the middle triangle, but I'm going to just end up getting stuck because there's not enough information about this side and this side. Whereas in the smallest triangle, don't I have my hypotenuse, which is y plus 1 over y minus 1, my short leg. And I have my leg being the geometric mean there. If you simplify this, cross multiply, you'll end up having a quadratic equation. You have to factor, and then you solve it. This one, same thing, no information on the altitude. I'm disappointed. So let's do hypotenuse over leg, which is a plus 4 plus 8 gives me the hypotenuse of the biggest triangle, right triangle, over this leg, which is 2a minus 4. Now, because this middle triangle on the left gives me the most information, I will use that hypotenuse, which is also 2a minus 4. Now I have my geometric mean over my other side. You simplify, you cross multiply, you'll end up with a quadratic equation. You factor, you get the solution. So for this type of problems, it's asking us to tell whether a triangle is a right triangle. Remember, the theorem that we use is the converse of the Pythagorean theorem, which states that you have to use your c squared. You're looking to see what happens if c squared equals a squared plus b squared. C squared would be 3 root 61 squared equals a squared plus b squared. Right? I have to, I hate using my calculator, but I'm going to use my calculator because I will need it in the next step. So, radical review, 3 root 61 squared is really 3 root 61 times 3 root 61. Remember I said treat these as variables, so multiply the coefficient. 3 times 3 is 9. 9, and then root 61 times root 61 simply just comes out. That's the left-hand side. On the right-hand side, I would have 15 squared is 225. 18 squared, I don't know on top of my head, is 324. So if this one should be 549. I'm still not sure if these are equals yet. So 225 plus 324, 549. Look at that. So I proved these two equal, therefore I can draw the conclusion c squared equals a squared b squared. So yes, it is a right triangle. So that only finished the first part. And then it says, if you find that it's the right triangle, it's not done. Find the length of the altitude. Where is the altitude for the right triangle? Right triangle only has one only has one altitude from the vertex of the right angle to the hypotenuse. So what is the length of this? If this is the right triangle, this obviously is perpendicular. What is x? It's too bad it doesn't give me information about these two segments. Otherwise, I can do a simple geometric mean by heartbeat theorem, right? So unfortunately, we have to crank it out using the legs. So let's look for hypotenuse over leg. Before I do that, it's really hard to tell which side is corresponding to which side. So I'm going to, in the biggest triangle, I'm going to use my tricks. 1 tick mark, right angle, 2 tick marks in this angle, right? And in this smaller right triangle, I have 1 tick mark, right triangle, so this one can only be 2 tick marks. And I noticed that x is opposite of the 1 tick mark. So this is a corresponding set. This angle and this side is corresponding. So keep that in mind. Okay? So let's see how we set this up. If on the smaller triangle, if I have my hypotenuse is 15, my leg is x. Remember, x is corresponding to the angle with 1 tick mark. Let's look at my biggest triangle. My hypotenuse is 3 root 61. My leg, do I use 15 or do I use 18? They're so close, visually it's hard to see. Remember, my x corresponds to 1 tick mark. You have to use the leg that corresponds to 1 tick mark. So now you can cross multiply, or you can actually cancel. I just noticed that. If you cancel that, you have root 61 times x equals 15 times 6, which is 90. And now if I'm going to finish this, divide root 61 on both sides, then you found your value of x, which is the altitude. You are not done yet. Remember, you cannot leave a radical roots in the denominator. It's not considered pretty by mathematicians. We want to see just good old integers. So now upstairs you have 90 times root 61. Downstairs you have 61. Double check this answer. It looks really convoluted. Okay, so the rest of it are all the same. You have to use the converse of Pythagorean theorem to see if they're right triangle. Hopefully they're not. If they're not, you're done. If they are right triangle, you have to draw your altitude, find your hypotenuse over like hypotenuse over corresponding legs, and then find the solutions. Here, use geometric mean theorems to find AC and BD. Okay, in number 13, if I want to find AC, notice, what do? Simple. In the biggest right triangle, my two legs is 16 and 30. So I just need to square them, add them together. I would have my AC squared. Okay? If I do that, let's see, what do I have? 16 squared is 256. 30 squared is 900, right? So I would have 1156. 1156, let's see if it's perfect square. I think it's 34. Oh, how lucky. Yep, so if I square both sides, AC would have 34. So this side is 34. Now that I got all three sides, what else can I do? I need to find BD. So BD looks like it's the longer leg, the corresponding side is the other side. So now if I use my leg theorem, I need hypotenuse over my leg, whether it's long leg or short leg. So let's see. If I have hypotenuse AC over, if I do the long leg, it should be DC. Then if I look at this triangle, this middle triangle on the right-hand side, I can have my hypotenuse, which is DC, over my leg. And in this case, what did I say the leg is? I did the longer leg. The longer leg would be 34, which is BC. So AC is 34. AC is 34 over DC. Can I do that? Because I'm looking for the altitude, dB. No, this is not quite right. Let me backtrack. Okay, so I'm looking for x. If I'm looking for x, x looks like I may be able to use this triangle. See if I can set up a proportion. And the whole thing AC, so the hypotenuse is AC over the longer leg, which is 30, which is DC. And if I look at this side, I can use this one. Actually, you know what? I was wrong. That's where the confusion comes in. So it would be better if I use this side, if I use this blue triangle. Why that is the case? Notice AC over DC. DC is my longer side. So if I go for this side, I have my hypotenuse AD. I know that, right? I know AC, I know DC, I know AD, but I don't know BD. It's easier. Out of this proportion, 4 elements, I know 3 already. So if I set it up, it's 34 over 30 should equal 16 over BD. Then you cross multiply, you can figure that out. Okay? This is 13. 14. Oh, good. I'm given altitude, but I'm not given any information about these two segments, so it's useless. I can't do anything. Is there anything I can do? Do you notice what happens here? Don't I have a right triangle with two sides? So I can use my Pythagorean theorem. So I can do c squared, which is 5 root 3 squared, should equal this leg, if I call this a squared plus this leg squared, which is 3 root 5 squared. So if I do that, that's 25 times 3, that's 75, equals a squared, that's 9 times 5, 45. No more squared. 45. So a squared would equal 30. A would be square root of 30. Is there a perfect square in the square root of 30? I don't think so. So a is root 30. But the good news is now, if I know this part equals root 30, I can use my, I'm asked to find BD, right? Oh, I'm asked to find AC, and I found AC. And now I have to find BD. So let's see. What's the best way to find BD? I can use my heartbeat theorem, find CD, and then I would know the whole length. Then I can use Pythagorean theorem to find this. But is there another way to find it? I think there is. I'm going to use this red color. Notice in this yellow triangle, I have my BD is my hypotenuse. My BC is a leg, 3 root 5. That faces tick mark 1, right? 1 tick mark. That would be 2 tick mark. So now if I go into my other triangle in green, my hypotenuse there is 5 root 3. And then I have to, in the denominator, I need a leg, and I need the leg that faces 1 tick mark, which is in that triangle, this is 1 tick mark. So the leg that's opposite of this angle would be the AC. AC is root 30. So you can cross multiply and solve it that way. All right, so that's number 14. Now let's do number 15. No information on the altitude. I'm asked to find AC, which is this whole length, and BD. No information on this. However, in this small triangle on the left with a green dot, I can use Pythagorean theorem. So the hypotenuse squared should equal, oops, that's an equal sign, 2 root 17 squared plus BD squared. Once you find BD, as you can see, you can use your heartbeat theorem to find AD. So AD, use your heartbeat theorem after you find BD. And then in order to find AC, you just add the two together. Add CD with AD. Okay?